good afternoon, good evening, depending upon where you are joining our session today. This is not going to be a Spira demonstration. So I will be focusing primarily on the quality aspects of how different KPIs can be put in. Spira comes with a lot of widgets and many other things at this particular point, but I will be drilling into some ideas about quality. Because at the core, Spira's quality is not just an add-on. So with that being said, let's move forward here. Most of you may already know me. I'm Dr. Sriram Rajagopalan. I'm the Global Head of Agile Strategy, Transformation, and Training Services within Inflectra. My doctoral degree is on organizational leadership through project management, connecting with virtual teams and emotional intelligence. Started my career as a software engineer, have continued along the curve, served an established program management office. And too many certifications. I ran out of space over there, so I left out a few things there. I have done a lot of training, teaching, tutoring, coaching, mentoring, volunteering, and many things across the world at this particular point. So that's in a nutshell about me. Today's focus is taking the ask the expert kind of a thought process here. We used to do ask the expert in Agile, ask the expert in risk management, and those kinds of thoughts. Now we are shifting our gears a little bit into the QA focus here. And the focus here is continuing to move into Spira here. So it's maybe a 30% foundations on theory, but remaining things will be primarily on the Spira itself. I would like everybody to get grounded on quality assurance and quality control. Many times people think they are both the same. They are not the same. They are completely different elements. They support each other. But they are not the same. So many times I've heard people that say, oh, I'm in QA, I do testing. To me, that tells me that, there is a lot more understanding about quality management that has to be understood very clearly here. And then move into the essential QA performance indices. Again, I am always of the opinion that you should measure what matters. There will be many, many, many KPIs that are available. But which one matters to you? That comes to your business process, the industry that you are operating in, and the product that you are actually developing. Depending upon the product and the business and the industry, some metrics may matter, some metrics may not necessarily matter. So it is very important for you to focus on measure what matters. Because if you measure the wrong one, going in the wrong direction very fast isn't going to help you at all. So that's something that I want to get grounded. And when you get grounded on the quality, the important element that you have to understand is the cost of quality. And I'm not sure how many of you may have heard about this cost of quality. So if you are able to relate to this, put a thumbs up or, something like that. But when it comes to cost of quality, there are two critical elements that come into play. One is going to be the cost of good quality. It's also called cost of conformance. The other one is called cost of bad quality, which is cost of non-conformance. Now, if you don't deal with the things on the left, you are going to deal with the things on the right. And that's not going to be a very good scenario. So you want to primarily spend most of your time on the initial elements over here, the cost of good quality. Now, cost of good quality also has two legs to it. One is going to be the prevention cost. Quality focus is primarily how do I prevent defects in the first place to occur? That's the quality by design thought process. So when you look at this, the prevention costs are focusing on how do I train the different people to make sure that they do what they are supposed to be doing. So the process adherence, thinking about quality from the beginning, at the time of engineering, at the time of test case design, at the time of thinking about requirements and stuff like that. So that's the element about training. The next one is more about the process documentation. What kind of existing processes do we currently have that enable people to do things right? And here is where I try to differentiate the importance of, being a leader in terms of setting these things up correctly. And then there are other things that come into play, in the cost of quality foundation, we talk about equipment, but this equipment does not necessarily mean, the machine. It could be anything that is relating to the facilities, equipments, materials, infrastructure, supplies, and non-resource of talent, and many other things. And in the cost of quality, we move into the downtime where we talk about a lot of different lean kinds of ways. Again, I'm not moving into that kind of a discussion here, but that's the thought process. And then coming into the thought process of giving people the required time to do things right. Rushing is not going to be very helpful. So not giving enough time for people to do things are not going to be helpful. So when you look into systems thinking, design thinking, all these elements are requiring people to think about creative ways of doing things. So that is the prevention cost. The next one is going to be, after this, you move into the appraisal cost. Okay, now that we have done what we are supposed to be doing, are we really moving forward into the appraisals? Now, the whole thing about prevention is about preventive actions. And if you look at the preventive action, that is supposed to be the foundation behind risk management. And now if you don't deal with that, you are moving to the next stage, which is the appraisal cost. Are we doing things right? Are we putting the right people in the right place to do the right things at the right time and stuff like that? And thus, many times people look into, from a software perspective, the testing. But testing is only one element of it. There is also this inspection. In lean thinking, we call this Gemba Genjutsu, which is about talking about management by walking around, doing walks to make sure that are people doing things the way they are expected to be doing, like wearing the goggles and stuff like that. The same applies even in a software world. Are people applying the right tools? Are they using the tools in the right way and stuff like that? Case in point about Spira, we have Spira that has the defects module right from the Spira test, because quality is part of it. And test takes into the Spira team, where we augment it with tasks and risks and other modules, and then we move it into the plan section, where we introduce the program portfolio and other components and stuff like that. So quality is inside the first edition within Spira itself. Now that's about how we actually do the tool the right way, and make sure that we are utilizing these things. And that's the appraisal cost. And that sometimes leads into, how are we doing training correctly? How are we putting our processes correctly and stuff like that? And this is about how we put the measure what matters kind of thought process. Now, prevention cost is what is focusing on quality assurance, which is QA. The next is going to be the appraisal cost, which is going to be focusing on quality control. And so when you take a look into these things, these two elements are part of quality. And if you miss this, you are going to not necessarily have the cost of good quality. And then you move into the defect module, where the cost of bad quality comes up. Now, that has two legs, which is internal failure. We didn't do the things right, we misinterpreted, or we thought we understood this, and all these elements come into play. The missed requirement, misunderstood requirements, didn't do it right, didn't follow the process right, and all those things. As a result, these things are going to be rework and scrap work. Now, it is still not completely very bad, because customers haven't still found that problem. We have found it as part of our testing, our pre-deployment and stuff like that. But then as you move into the next stage, which is external failure, this has already reached the customers, and customers are having to deal with the challenges. Now it's going to be having a lot of challenges, which is like liabilities are coming into play, the warranties, the recalls, the taking back all this information and reworking them, and maybe even the lost business, lost goodwill, and so all those things elements come into play. So we don't want to move into those elements, because if you look at the cost of quality, prevention is better than cure. It is easier to correct a mistake that has not even happened than to deal with the error that is already out. So that's the idea behind this. The more you are able to put time and energy on the cost of good quality, the less you will have to deal with the cost of bad quality. That's the foundation behind cost of quality here. Now that I have talked about those two elements, let me expand on this a little bit, just on the quality assurance and quality control alone. So quality assurance at its get-go is going to be focused on a little bit different thought process from quality control. And this is one of the reasons why I kept telling quality control is important, but quality assurance is even more important. We talked about this in the build quality versus assess quality. Now, what does quality assurance mean? It's preventive. It's process driven. Remember the process documentation. We need to write down, for instance, even in the DevOps thought processes, you have to write how this CI/CD will be done, right? The DevOps infinity loop, when you take a look at this, the process has to feed so that you are able to put those thought processes in terms of how subsequently things will be done. So it's more of a preventive thought processes. When you think about risk breakdown structure, what quality means to us, how will we do quality planning and stuff like that. And now you are looking into the element of fitness for use. It's not always conformance to requirements alone. It is fitness for use. Now, as part of that, we focus on validation. Validation meaning like, at the extent to which the customers are deriving the benefit by making sure that all our processes and are in correct places and are delivering the product value. When it comes to quality control, it is more reactive. Okay, now that I have known this requirement is not returned correctly, or this test case isn't done correctly, or when I executed this, the environment wasn't set up and stuff like that. And so it's just taking more of a product focus. It's not a process focus. As you consume the process, how you are actually making sure that the product is actually being the way it is. And now you are focusing on conformance to requirements. And most often when people say testing, it is just the conformance to requirements. And then we move into verification. Verification is all about, you said you will do this, I verified it. That's what testing means. So when we talk about testing, testing takes the quality control, but you have to understand, in order for quality control to work, you need to have the quality assurance. This is a cyclical loop. One without the other, you will not get the benefit of truly what quality is. So with respect to KPIs, again, as I mentioned, we have to start thinking in terms of the measure what matters, right? So this is just my thought based upon how we have done supporting quality in my previous experience, as well as in the use of Spira in multiple industries and stuff like that, of different companies and stuff like that. So one is going to be looking at the defect analysis, and I have slides that will go through each and every one of them, but I'm just going to give a bird's eye view here. Defect analysis. So now that we have a defect that is happening, how do we take a look at the defect? Not necessarily from a specific product focus, but from a quality assurance standpoint. So please don't take everything in the quality control angle. Take a look at this from a quality assurance angle. Now that I know what has happened, how do I make sure that it is getting better, faster, cheaper, and all those elements? Right now, looking at this from an effectiveness angle. So what does an effectiveness mean? Effectiveness is about leadership, like doing right things. Are we having enough coverage of our work? Are we having the proper amount of cycle time where people are able to consume the work and get the things to the finish line? And how reusable are all our test cases and stuff like that? The next one is about efficiency. Now that they have been working relatively fine, how do I make sure that they are, doing better in terms of, okay, what can I automate from this particular angle? How are they working for the entire life cycle repeatedly? So that's about regression and overall software health, in terms of stability and stuff like that. Again, I have to repeat my disclaimer here. This is one way of measuring quality throughout the life cycle, not necessarily in one particular product, in one particular segment alone. The way I am trying to come up with may not necessarily work in different industries, different products and stuff like that. And we are more than happy to take some input and work with you if we need to. But this is just an idea over here. So defect analysis. So defect detection rate. It is about measuring the effectiveness of the software. And again, these two thought process, effectiveness and efficiency, will keep rotating, okay? So the software's effectiveness in identifying defects and bugs in the development lifecycle. This is about, if you look at the diagram that I have given, there are lots of different iterations that are listed, not necessarily requirements. Now, I have listed all these iterations that I have, or phases, if you are using predictive approaches. And I'm taking a look at this and say, across every iteration that is moving in the sequence, how many counts of defects are coming. That helps me understand, did I consume more in a particular sprint or iteration or wave? or did we actually give a large, big epics or features that had a lot more risks associated with that? So this is an indication of that. It's not necessarily to come and say, oh, if I'll take a look at this library system release 1 that has 25, or if I go to iteration 001 that had 10, and then we look at 2, it is 4. And so it's not an indication of, oh, okay, reducing this, but it's also an indication of, did we take on more than we did, or did we actually have more ambiguity in things that we did? So it's an indication of those kinds of things. The resolution time is more about how long did it take to actually figure these problems. And again, I'm not trying to measure by each and every one of those individual defects, but I'm taking a look at this and say, if we have enough time to work on certain things, the critical things are the one that I want to work on. So if you take a look at this example here, this is all, example scenarios that I put. So the numbers may or may not necessarily work in your in your situation. But if you look at this, the critical thing, the amount of time it took to solve is only about 402 weeks. Again, I'm measuring in weeks over here. That's a lot of time. That's a lot of time, and I am pushing it. So this is an example of how we are taking a look at this and say, what do we have to do to reduce this? Maybe more process, maybe more people, maybe more automation. That's the thought process. Quality assurance is more about preventive, process driven, and stuff like that, right? The effectiveness, the test case coverage. How many test cases do I have to verify and validate? It's not like one requirement to one test cases. In Spira, we have the traceability where you will be able to add multiple test cases. And most often there is always a one-to-many relationship. One requirement is tested by many test cases, and one test case tests multiple requirements. In the concept of quality, we go into the white box testing, black box testing, gray box testing, and many other things. I'm not going into those details, but here is where you're looking at this, the positive scenario, the negative scenarios, edge cases, and stuff like that. So now this is being used to evaluate how good your test case coverages are. Then the test cycle time. For every particular test case that you have identified for your specific iterations, you are taking a look at this and say, where is my bottleneck? So how long did it take to actually, perform certain things? So as you see over here, it's going to be across the spectrum here. And now taking a look at this and say, all right, if I take a look at a simple example, the 21 test case number 21 here, that, when I ran it for the first time, it took some time, but then it had more time, then it had more time. So what's going on here? Are we adding more to the same test case repeatedly with additional test steps? Or are we taking a look at this and say, should we break this into multiple sequences and stuff like that? So this is how you are getting into granular, modular test case writing thought processes and stuff like that. Then the test case reusability. Now, if you did this correctly, then you would be able to take a look at this and say, how can I create modular test cases as well? And I'm seeing somebody is raising their hand. If you don't mind, please put the thoughts on the chat itself. I'll pick it up at a later point. So that's about test case reusability. What test cases I have written so that they are in a modular fashion. Now, a simple rule of thumb that I normally recommend is, if you take a look at a test case, it should be no more than 10 in terms of test steps that you have. So if you are having like 25 to 50 different test steps, that's not scalable anymore. It's because it's not manageable. And when scalability and manageability is not necessarily in place, it is not going to be stable. I call this my SMS. Are you able to have a stable, manageable, and sustainable thought process behind this? So this is the thought process behind the test case reusability. And as you are moving this needle a little forward, you are taking a look at this and say, all right, among the existing test cases that I have available that are, literally stable or manageable and stuff like that, how can I now consider them as potential candidate to be able to automate them in the future? Not all test cases are automation candidates, but some candidates would be potentially evaluated on an ongoing basis. And as you automate them, you also need to take a look at it from another angle and say, how do I make sure that these are still continuously automatable elements? as your screen size changes. Maybe one of the existing automation candidates is no longer an automation candidate. So there also needs to be a maintenance thought process of how do you keep those test cases, the automated test cases, still workable and stuff like that. So that is another process to take a look at. And then the regression efficiency. As you are associating more and more test cases at the product level to evaluate, okay, all these things are working fine, and now I have added new functionality. I want to make sure that the previous ones are going to be working fine. That's your regression thought process. But how do I make sure that those things are all working fine? So you can look at it from a release standpoint and say how my release is actually working on. So in this example here, I'm able to say how many were run, how many were not run, how many passed, how many failed across every iteration that I'm looking at. And now over a long period of time, I'm able to look at this and say, I have a reasonable good feel that, my previous working functionalities are not broken. And finally, when you do all these factors one by one into the thing, you can take a look at all the different defects that are available, still not resolved at this point, and take a look at this and say, how many were low defects, how many were medium defects, how many were high defects, how many were critical defects. And again, the low, medium, high, critical are up to the business to determine and, qualify. I have some thought processes as to how I have actually come up with, and that's the example that I'm going to move forward with at this particular point. I'm moving straight into the Spira demo. Let's move forward and showcase these things. And in Spira, you can go and create a requirement. And when you are creating a requirement, you are able to come. I'm just going to pick up something random here, and you are able to go into these requirements here and also look into the test case coverage and add those traceability element over here. So here you can see that I have added a test case here. If you want additional test cases, those things can be added very quickly here as well. So these are things. Again, I'm not moving into the Spira demo here, so please forgive me on that. So I'm going to go straight into this domain here and move into the edit graphs over here. This is where I have set up a few important queries and stuff like that. So let's go inside this edit graph query. And I have created a lot of graphs at this particular point. And all this information, I'm going to show how we are able to demonstrate. Before that, in Spira, by default, when you are creating a specific product, you want to be able to set up the product dashboard. Now, there is also a product dashboard that is accessible right from here. I'm accessing my cloud instance of Spira Plan here. Now, if we go inside the Spira dashboard, the Spira dashboard is divided into 3 segments, which is general, development, and testing. And this testing is where I am harping towards at this particular point. Now, if you go inside my testing, there are a few things that are already available from Spira. We are already shipping this within the Spira editions. Now, some of them will not necessarily apply to all editions, but most of these things that I'm going to show are applicable. So top open issues. What are the top defects that you consider as an issue? So issue from a project management standpoint is something that has already happened and you need to deal with that. Risk means it has not happened. And the release test summary, there are certain things that like how the release test efficiency is working and stuff like that. Requirements coverage for every particular release that I have. I can go inside and look at this. And there is also a release picker where I'm able to go and modify this for a specific release or a specific iteration and stuff like that here as well. Regression efficiency, test case cumulative progress, test execution status, test set status, test run status, how long the incidents have been left unattended, all the currently pending runs for a specific release, the coverage of the incidents at this particular point for every test case that you have executed, the requirement incident count. This is an important one. It is called defect density in a quality assurance standpoint. This is also taking a look at this and say how many requirements for a specific release have defects associated with that. That means potentially people did not understand this. It was probably not written correctly, or there was too much to this, or it was clearly misunderstood and stuff like that. As a result, you are seeing more and more defects over here. So this is also an indication of how good requirements and test cases and testing is happening at this point. What are the incidents that are open? an incident summary. And this incident summary has a lot of additional details also. I can go take a look at this from a bug standpoint alone and stuff like that. And also the top open risk. The risk module is associated with Spira team and Spira plan, not with Spira test. Except for this one particular one, Spira test will have all the elements that I just showed you. And risks can be associated with the test cases, risks can be associated with risks, risks can be associated with requirements, risks can be associated with incidents. And now you are able to also have a feel for how do I do risk-based testing, which is a different scenario. We'll get to that at a later point. Now, this already exists. So this is where I was telling, like, measure what matters. Set up your QA dashboard so that everybody in the team knows what they are expecting to measure. So this is one important thing that we can actually do at the very start. But as I mentioned, some of those different matrices that we just talked about, how can you actually do those things? And this is where you go here. You can create your own custom graphs. And I'll show you later where those custom graphs are going to be added at this point. Now, I'm going to go one at a time, not necessarily in the same order we talked about here. So I have put a few things over here. This is a query I have written here at this particular point. My goal is not necessarily to go and explain every query here, but a lot of the queries that I have written here, we already have, knowledge base article, KB articles that we have written. So if you look at this particular this particular one, this is about software stability metrics. This is exactly what we have right here. So this is the query I have written, and this query is listed here. And we are also talking about the explanation of this particular query and what the output is going to be looking like. So when you actually look at this query, I'm taking a look at this and say how many incidents are currently logged against a specific category of a release. And I'm looking at this and say, combine all these things and provide me. It's a very complicated query, not a straightforward query. So as you can see here, there are multiple simple queries that I'm joining by union statement, and then I'm bringing all this information. So when you take a look at this one, it gives me this data point. When you look at this data point, I'm able to build this kind of a query graph right here. Now, this is what I'm already showing you there. So now you are able to say the low defects, the medium defects, the high defects, and the critical one for every release, count them towards a particular category and sum them up. This is what I have done at this point. The same logic applies, and I'm not going to change that, but I'm going to move forward to the next one. Now let's take a look at this, these one, automated test cases. I'm just going to go one by one at this point. So when you take a look at this particular one, I'm taking a look at this and say, how many test cases that I currently have against a specific test run, and then take a look at this and say, if they are not deleted, how many of them are potentially automatable? So now some thought process must exist in your business process as to what I consider as an automation. In this particular case, it's working fine. So I'm immediately saying like, this is automation worthy. So if you look at this, I'm saying like, okay, this is test case name, and I'm calling them automated test case. And if it is an automated test case, these are my criteria that I'm taking a look at this particular point. Now, if you look at this, I'm able to say these two test cases that I currently have are potentially automation worthy candidates. Now, you can just sum up all these things without necessarily all the details behind the test cases and just sum it up as well. Now, the reason why I'm bringing these things is, just in case you want to know what was the test case we are talking about. So I'm bringing these things here. So there is different ways of interpreting these graphs here as well. So you can take a look at this and say, these are the two test cases that we are talking about. So I'm able to put this in a graphical form here as well. So let's move forward. So pretty much all the queries that I'm talking about are all properly explained. So the logic is too detailed for somebody, because I can make an assumption that everybody will be able to understand the SQL logic here. So that's why I'm not going into the detail behind the SQL, but for anybody that would like to spend a little bit more time or take this query, apply it in your in your product setting or make some changes and stuff like that, please go ahead and do that. And for every one of those things, I am explaining each and every one of them. So this is an automation thing. Here I'm explaining this is for inner and outer queries. It is using the test run type equals 2, which is an automated example. So these things are all, explained in detail here. But for the sake of this webinar, I'm not going into the details behind each and every one of those queries. Now let's go down to the other one, which is about this one. So let's take a look at this query. Some queries are complicated, some are relatively easy. So here I'm telling, okay, select this particular. This is probably a simple one that I can explain. So you are basically casting this to be a string because test case ID is a number. So you need to cast this as a string here. Along with that, I'm appending the test run ID, and then I'm taking a look at this and say, if the end date is not null, which means as part of your business process, you have to make sure that these criteria are met. If these criteria are not met, then it's not going to work for your specific thing. And then I'm using like, okay, how many seconds have elapsed since the time this test was started and the test was marked as finished. So if the test date is null, then this is not going to work. Or you started the test run, but you never finished it, and that is not going to be working. And then I'm taking a look at this in terms of the current date. Okay, this is the time it took. Now, how much time did it take from the time the actual thing started to now? So current date and time right now. And then I'm putting all these criteria for, this particular project ID, this particular, deleted criteria in all those things I have listed over here. And I don't want anything to be included in this if the test case is marked as not run. Okay, so I'm not looking at anything that is not run. I'm only looking at things that have already started but are on different states at this particular point. Now, when you take a look at this, this is the test case run. So if you look here, I basically said the test case ID and then test run ID. So I'm able to look at this and say different test runs took different times. Why did it take that much time? So I'm taking a look at this for subsequent analysis. This is not an indication of this tester took more time in this release, and a different tester who was assigned to a different release took little time. It's not an indication of that. It's an indication of why did it take more time here. There may be many other contributing factors over here. So this is like digging into that process, digging into, did we give them enough time to do the work? Did we use the right tools and stuff like that? Maybe there is a new CI/CD process that was introduced. And so it took more time. We don't know that. So this is an indication of how we are taking a look at these things and stuff like that. So now you are able to put this in terms of a chart here and see how it is working out. Just moving down in that same line. Now taking a look at this in terms of the test case reusability. So you are able to figure out these things in terms of how the different release name is coming. You are joining it with different elements here. Again, sometimes somebody may be taking a look at this and say, Sriram, you are putting all these tables here. Where would I get this information about tables? So again, let me go here, go to the documentation. You can access Spira documentation right from the Spira. You can also, access it outside. The main difference is if I access it from within the Spira, it is a context sensitive documentation. So it knows where I am in the process. So it will basically come back and say, you are in this area, so I'm going to take you to that particular jump location, and you are able to figure it out. Now, once you come here, if you go under the reporting section, there is available report tables. If you look at that available report tables, all the tables that we have listed here, they are all listed in this particular one. So if you take a look at any one of those tables, for instance, if I take a look at test runs, for instance, it tells me this is the test run ID, test case ID, name, all the properties that are associated with this. So you have pretty much all this information right at the tip of your fingers. You just need to spend some time to, do these kinds of things. So now I'm able to run this, take a look at this one, join with other information, and take a look at this and say, now for every particular release that I currently have, what is the count it took to actually perform these reusable test cases. I can now come back and say this is the graph, or certain graphs will work in certain elements based upon how you are doing it. So if I put this in a line graph, it works, but it may not necessarily render it fine and stuff like that. So it's up to you to figure out what those things are going to be. So just moving down, let's talk about these things I've already talked. Coverage, this is the one. Defect detection rate. Again, the query is pretty straightforward here. Like I mentioned, all the queries are explained. So if I look at the data comes up, and I can take a look at this in the form of a bar chart here, because this is only one section here and one number here. So I can provide a bar chart or donut chart here. So I can do this. Now let's go down and take a look at the release test efficiency. Now this is looking at it from a specific release. So for every release, what was not run, what was not applicable, what passed and what failed and stuff like that. So I have compiled these things at this particular point. And last but not the least here, I believe I covered all of them. Okay, I covered all of the release test efficiency was the last one, so I covered all of them. So now I showed you how these queries can be written, how you can join these queries and stuff like that. Now I'm going to go back and build my second QA dashboard here. So let's go to the library information system. And as I mentioned to you, the product dashboard has pre-written widgets. So these widgets are extremely complicated widgets at this point. Some are tabular, some are graphical, some have a lot more additional, information associated with them and stuff like that. Now, if I go into my reporting section, once you have your graphs all properly written and structured like that, in the reporting section, you have two different areas that you can play with. One is going to be the standard reports that we already have available. You can create custom reports of these things as well, but these are XSLT based and not graphically interfacing here. Now you also have a lot of graphical widgets. So if I go inside my plus symbol here, I can see a lot of available widgets already available. These are further than the product widgets that Spira makes it already available in the system. And now you can take a look at all these things like incident date range, testing date range, requirement summary, and many other things that are listed over here. Some like I mentioned, the task, the risk, and stuff like that, those are all associated with Spira team and Spira plan and stuff like that. As a result, they may not necessarily be relevant, but anything relating to the requirements, test case, test sets, incidents, they are available on all editions of Spira. So you can come and add these things here, but I'm also going to come and see how you can add the graphical widgets that you added. Now, I just want to clean these things so that you can only see what you want to see at this point. So I'm going to go here, and let's say I don't want this task and I don't want this requirement. So I just deleted these two things. I've left these pre-existing widgets that seem to be okay for my business process. Now I'll mark this complete and click on this plus symbol again. Go to the custom graphs. Now I can add certain things here. So let me pick up something here. The 8 matrices that we talked about. This is the one that I talked about, G for software stability. And if I scroll further down, I can add the automation test case, test cycle time, and defect resolution time. I'm going to add them to the left here so that my dashboard looks evenly distributed. Let's add them here. Okay, now I'm going to look. So defect resolution is added, cycle time is added, automated test case is added, and software stability is added. Now let's take a look at the other things here. Release test efficiency and test case reusability. Let's add them to the right side here. Look. As soon as I hit this, now the software stability is coming, test case reusability has come, test case automated test case coverage. So pretty much all the things that I talked about, all these data are right now showing up right here. Now this gives you a very good bird's eye view of how measure what matters comes into play. Now I am able to say these are product dashboard widgets that Spira already makes available for you. In addition, we have other widgets that you can create or graphs that you can create based upon what matters to you and put them right here. And there are also other webinars where we have talked about earned value management, where you can put earned value for scope variance, cost variance, schedule performance index, cost performance index, and stuff like that. And if those are relevant, you can come here and add here as well. But in this particular example, I was focusing primarily on the QA processes and earned value management as both the leading indicators and the lagging indicators. And most often people only look at the lagging indicators, and that's why I'm not showing them over here. Now, your dashboard is pretty much set up. So anybody that has access to Spira at this point would be able to come within your product based upon the roles that have been given to them. They would be able to come and take a look at both the product dashboard, the testing side, as well as the reporting side that you have created and work with them and see how are we doing from a metric standpoint. So in your retrospectives, you can run these things and say, how are we doing? What are the areas that we should be looking at? There are more time that we are spending to resolve the critical bugs. Why? Should we actually change our process? Or did we run too fast with the CI/CD processes? Why are we not looking at the manual test cases and potentially automate them? So these are all questions. These are all the powerful questions that you can ask from a systems thinking perspective and say, how can I put quality assurance in place? Again, remember, I'm using all these thought processes to drill down the point that quality is all about what you consider as important for your product, your team's health, your business health. So when you put those thought processes, goes back to the quality assurance from a preventive process-driven perspective so that you put the right things in the place so that people can actually be measured on from what they are doing in the product. At this point, if there are any questions, I would like to answer them. Was this helpful? Give me a thumbs up. Well, yes, what we can do is all these things that we have talking about in this particular section, the quality metrics for the defect detection, what is this, resolution, pretty much all these matrices that KB articles that we have, we can definitely package them and send it as part of the presentation when it is available. We can send this to you, but if you need to have access to this a little bit in advance, please reach out to us. And while you do that, let me also show you this. Spira has a bigger thing called, inflectra.com report. If I go right here to the knowledge base, you can go inside this knowledge base and start looking at the articles here as well as you can go to the custom reports here on the Spira platform, and we have a lot of different things that we have written. So for instance, in the quality metrics defects resolution time, this is the one that I was actually showing. So you can look at this right here. So yes, we can send this to you, but you have access to this right now as well. Is the dashboard set up per person or is it universal across? That's an excellent question, Laura. The dashboard, if you look at the dashboard here, if I go here, what Laura is referring is this dashboard. This dashboard is set up for the entire set of users. It's not for any individual user. It is for all the users that are using the Spira at this point. So long as they have access to this particular project or product, they would have access to this. Same logic applies, to the product dashboard. The product dashboard is also not set up for any particular user, but all of them. The only thing that is going to be configured for a specific user is, my page. My page is any widgets that basically have data that is assigned to me will show up here. So if the owner field in an artifact is assigned to you, then you are going to see this. That's the only place where it is customized for a specific user. For instance, right now I'm system administrator, but if I log into the same thing as somebody else, then whatever has been assigned to that somebody else will be what will appear here. But if they go to the product dashboard, they will still see the same information there, and they will still see the same information under the reporting. Excellent question, Laura. Thank you for asking that. There's one more question. If one product has custom fields with a graph for those fields that are not in other products. Let me read this one time. If one product has custom fields with a graph for those fields that are not in other products, I'm assuming the graph for the will not work. That is a true statement. So the products are all coming based upon a template. So if you have, let's say, two products, and those two products are coming from the same templates, and the custom properties are set up at the template level for the products. And so when you run those reports, if those products do not have the custom fields properly filled, then that's not going to work. So sometimes you will also get an error message on this. So for instance, I can simulate this, but let's say you have this particular automated test case. So I was using a field to say this is automated or not, right? Now let's say I have not used this for some other product, and that some other product will now basically not show anything here at all. So let's say I go to, let's say I go to content product. The content product does not have any of those things. Now you see here, whatever I had originally configured for the reporting portal at this content product is what's showing up. None of those other things that I had originally set up are showing up. So the configuration is at the product level. But if those products are not properly set up or the data for those products are not there, then you will either not see them, or if the graph is still relevant, but you have not filled the data for this, it will basically say, invalid data because I can't run the query. Thank you, Laura, for that question. Michael, thanks. Good to have a specific KB to consider all options for reports. Best to have it obvious and advice. Thank you, Michael. We will send you all the KB articles. As I mentioned, you have access to them right now, and there are more things there. So in the KB article, if I go there and take a look at, earned value, or EVM. I don't know how I have called. Oh, there you go. So implementing earned value management and stuff like that, leading and lagging indicators. So schedule metrics. So for instance, I basically said, this is the variance analysis, index analysis. If you want to write a query for this, here is the SQL query, and what are the expectations, explanations here, and how this will work. So pretty much all that information is going to be available. Some of these are good for a report perspective, but some of them may not necessarily render very well, because if I take a look at this query, it's not graphically oriented. So you can expect those things to be in the reporting portal, but you can take this query, say for instance, I like this query. I like this query, but you see that this is not graphical. Now, in that particular case, if I go to this section, under the edit reports, you can create a new report, give it a name, EVM demo report, EVM demo report. I'll leave it as the HTML alone. Give it add the custom section. It is very important. I am clicking on the custom section, not on the standard section, because I'm going to write a query. Give it a name, demo query. Give this table query here, review result. In this particular case, I'm not seeing anything because I will probably be having the sprint phase, minor release, and all those things properly filled in, and the project ID and stuff like that. Now, once you feel like that query is looking fine for you, you can hit the create default template. This will create the XSLT. Now you have saved it. You can save this query. Now, when you go to the report, library information system, assuming I have data for that report. If I go inside here, the EVM demo report, there you go. I can click here, run it in HTML, and if there is, assuming there is some data there, it will start showing up that info here. No, there's not much of a data here, so that there is nothing showing up there. But that's the way you will run this. So when you run these SQL queries, see if they are graphically oriented or just tabular data based. Accordingly, you should put them in the reporting section of the custom or the edit graph sections. Okay, Nicole has a question. I created a graph but don't see the option, custom graph option, add, remove items on the list. Do I need to enable this somewhere? No, I created a graph. If you created a graph, then you should be able to. So when you go into the reporting table, sorry, not the reporting section, click on the plus area. There should be a custom graph option. If you created a custom graph, then that custom graph will appear on this section. And now you can add this because there are lots of other things that we have here, like Spira app widgets, custom graph, available widgets, and stuff like that. So most of the things that you wrote as a custom graph will be available under this custom graph section. But by default, you will be coming into one of these previously, clicked one. And now if you click here and keep looking for the custom graph you were searching for, then you will not see it. So go to the custom graph section and you will be able to see it. Michael has one more question. I have written many reports and graphs. Good to have a base from Infectra. Thank you. Appreciate that, Michael. Yeah, take a look at that KB article and that will be KB article section. It'll be good. If there are more questions or you have ideas and suggestions like that, please reach out to, our marketing department. They will be more than happy to, forward those requests and, look into them. But if there are anything relating to the content, like anything else like that, reach out to support. But please mention this webinar and stuff like that, because otherwise it's going to be very confusing for people to understand what is the context in which your question is coming. Have a wonderful day. Thank you very much.